Chapter 8, Section 4 is about factoring again, but if you were with me in the last section, we talked about the case where you just had x squared plus bx plus c, so the number in front of x squared was a 1. Now in this next section, I'm going to show you what happens if the number in front of the x squared is not a 1. So if it's a 2, 3, 4, 5, or a negative number, any of those different types of options instead of just a plain 1. When we factor problems that look like this one, we don't have a shortcut like we did in the last section, where you can just look at the problem and set up your t-chart and go ahead and try to find those two factors. Instead, what you're going to have to do is rearrange or rewrite your problem, and we're going to actually go back to what we did in section 2, which is by grouping our terms together and factoring by pulling out the GCF. So I'm going to show you how this works. Now I'm going to say off the bat that this is a longer process, so this takes a little bit more time for us to kind of wrap our heads around. So it's okay if the first time that you try to do a problem, you maybe aren't totally sure, or you get something wrong, or you get stuck. The important thing is that you practice these types of problems, because this is probably the hardest case when it comes to factoring. And if you can figure out how to do this one, you can apply this method to any problem that you see in the future for factoring, and always use it if you don't remember those shortcuts. So if you can really master this, then you should be good to factor anything else that you come across. Now, when you factor, you want to make sure that it's written in order. So sometimes the problems that they give us aren't maybe in that descending order that we need it to be in before we can factor. So for this one, I need that 3x squared to come first. And then I need the minus 17x to come next. And then the plus 20 equals 0. So I just had to do a little bit of rearranging there. The next thing that I am going to ask us to do is you're going to identify 3 numbers in the problem, and they're going to be represented by letters. So the letters that we're going to use are A, B, and C. Those are going to be the numbers that, if you have it in order, kind of just go right in front of those two terms with the variables, and then the number at the end. So your 3 is going to be your A, this negative 17 is going to be the B, and 20 is going to be the C. Okay? So those are the 3 things that you have to be able to find first, and they match what I had up here. That's where I got those from. And the reason why I'm having you identify those is because we're going to have to do a little bit of work with these terms to help us be able to factor this. So the first thing that you're going to have to do is take your A term and your C term, and you're going to have to multiply them. So you're going to take 3 times the 20, and that comes out to be 60. Then your B term, which is in the middle, is going to be negative 17. Now that you've done this, we're going to go back to those charts that we made in the last section. But we had to change this a little bit because I couldn't just grab the 20 and put that in, and grab the negative 17 and put that in and try to factor it like we were doing in the previous section, because it wouldn't work. You'd get stuck. You wouldn't have anywhere to go with it. So instead, we're going to multiply to 60, that A times C quantity, and we're going to add to that negative 17. Okay, now in this case, because you are dealing with a bigger number like 60, it might take you a little bit of time before you actually find the factors. So you might have to take 6 times 10 and then add those and see that you got 16. So you're not quite right. And even if you tried to switch them to negatives, because you know that you need a negative 17, these still aren't going to get you to exactly where you need to be. So we're going to have to try a different set of numbers. For example, let's try negative 5 and negative 12. That would multiply to 60, positive 60. But if I add negative 5 and negative 12, then I get negative 17. So these are going to be my magic numbers. Now what we're going to do is not go straight to our parentheses. We're not quite ready for that yet. Instead, we're going to take this equation that I have up here, and we're going to rewrite it. So I'm going to put the 3x squared first. Now, instead of the minus 17x in the middle, I'm going to grab these numbers that I had down here, and I'm going to put them in place of that negative 17x. So my numbers are negative 5 and negative 12. So I'm going to put minus 5, and I'm going to put an x next to it first. And I'm going to do minus 12, also putting an x next to that one. And then I'm going to put my 20 on, so plus 20, and then equals 0. So what we're doing here is we're rewriting this equation that we have, and what I'm going to do now is kind of go back to the factoring that we started with, which is when you have 4 terms like this, we group. So we group the first 2 terms together, and we group the second 2 terms together. And notice how I pulled that negative in with that 12 inside the parentheses there. Then what you do is you look at your groupings and you try to decide, is there anything that I can take out of my groupings here? So from the first set, I can't take any numbers out of 3 and 5, so I have to kind of just leave those alone. But I have x squared and I have x. I can take out an x. And that leaves me with 3x minus 5. Now, remember when we were grouping in the past, the really important thing was what was left inside the parentheses needed to match. Okay, so I know that when I factor this, when I take something out, that I want 3x minus 5 to be left. So if you're not quite sure maybe what we're supposed to factor out, take a look at the 20. It's going down to a negative 5. So you have to kind of ask yourself, 20 divided by what would get me negative 5? Hopefully you think negative 4. Then if you check, negative 12 divided by negative 4 is positive 3x. And 20 divided by negative 4 gives you that negative 5. And then if you look, the pieces inside your parentheses are matching. Then remember what you do is you grab the pieces that you pulled out front, so the x and the minus 4. That goes in its own set of parentheses. And then the 3x minus 5, that gets brought down as well. And then we do have this being set equal to 0. So we saw this happen in the last section where sometimes you have it set equal to 0, and that means that you need to maybe solve it. So for this one, you're going to have to set both of these quantities equal to 0. So you're going to set the x minus 4 equal to 0, and the 3x minus 5 equal to 0. Okay, this one over here is a little bit on the easier side because we just have to add the 4 over. And so we're left with x equals 4 for one of our roots. This other one, you're going to start by adding 5. And so that would leave me with 3x equals 5. Then I have to divide by 3. And I'm going to leave my answer here as a fraction. So I'm going to say x equals 5 over 3, 5/3. Okay? You won't always have to solve it. There will be times where you just have to factor it. And so if you left it here, that would be okay and acceptable. If it has that equals 0, or if the directions say to solve, then you're going to want to make sure that you do take that extra step. All right, let's take a look at another example here together. Now, before we jump straight into the same steps that we did in that last example, I want us to just take a look at these numbers that we have in this problem. We have a 6, we have a 22, and we have an 8. What I think that I'm going to do first to kind of make this problem a little bit easier on myself is I'm going to take a 2 out of everything. If I take a 2 out of everything, that becomes 3x squared plus 11x minus 4. Now, the reason why I'm doing this is because I'm able to simplify this just a little bit before I get started, and it's going to help me deal with smaller numbers. So instead of having these large numbers on the inside of my parentheses, now they're a little bit smaller for when I have to do my AC business. Now that 2 that I took out front, that's going to have to stay in the front for the remainder of this problem. We're not really going to do a whole lot with the 2, but it is going to have to stay there, so we just have to make sure we don't forget about it. Okay, so if we look on the inside here, the 3 is your A, the 11 is your B, and that negative 4 is your C. We're going to start by taking A times C. So 3 times negative 4, which would be negative 12. Our B term is going to be 11. And now we set up our chart. I want to multiply to a negative 12, and I want to add to an 11. Okay, if you're thinking about this to yourself here, you're running through the factors of 12, like 2 and 6, 3 and 4, 1 and 12. And I think the best option for us is to do positive 12 times negative 1, positive 12 plus negative 1. So then what we're going to do is take this equation up here. We're going to rewrite it. Remember that 2 sits out front. I'm going to put that 2 first. Now I am going to use kind of these more squarish, rectangular shaped brackets, just because when I get to the point where I have to group, and that involves me putting in parentheses, I don't want there to already be parentheses there because it gets a little confusing for some students when they see like double sets of parentheses. So I'm trying to save us a little bit of confusion here by using different brackets. What I'm going to do now is rewrite my equation. So if you remember how we did on the last one, we keep the 3x squared. Instead of writing 11x, we're going to replace that with these numbers, so 12 and the negative 1. So plus 12x minus 1x or minus x, and then minus 4. Then we have to do our grouping part, and this is why I did those different style of brackets, just so you can see my parentheses now of my grouping. So I still need to bring down that 2. From my first group here, I can take out a 3 and an x, and that leaves me with x plus 4. Now, the second set, I need it to look like x plus 4, and it's really close. It just has the wrong signs. So if you remember, what you need to do to switch those signs is take out a negative 1, and that'll create the x becoming positive and the 4 to become positive as well. Okay, the last thing we need to do is just clean this up by writing out our simplified factored answer here. The 2 is out front. In the first set of parentheses, I'm going to take those terms on the outside, the pieces that we pulled out, which is the 3x minus 1, and then the x plus 4 on the inside. And there's our final answer. All right, on the back page here, there are 2 practice problems. I want you to go ahead and take a couple of minutes, so I want you to pause the video and try to do this problem and try to do this problem. I will let you know that this example here, this example here is, I should say, a trick problem, but something weird happens in this one, so if you're not quite sure what to do with it, go ahead and just wait for me to go through it. But go ahead and give that one a go if you're feeling up to it. But for sure you should be able to attempt this first practice problem doing what I did on the previous page. So go ahead, pause your video here, try to do these problems, and then keep watching to see how they should have worked out. All right, what I did first is identify my A, B, C. My A times C is 5 times 6, which is 30. And my B is 13. So I need to multiply to a 30 and add to a 13. The numbers that do that are 10 and 3. So then I should have rewritten my equation here. So it said 5x squared plus 10x plus 3x plus 6. If you happen to switch those 2 terms in the middle around, so if you put the 3x first and then the 10x, it should not affect your final answer. Your factoring might look a little different than mine, but we should have ended up with the same 2 sets of parentheses with the same stuff inside of them. What I do next here is I group. From the first set, I took out a 5x, and I was left with x plus 2. And from the second set, I took out a 3, and I was left with x plus 2 as well. So for my final answer, I wrote 5x plus 3 and x plus 2. All right, let's talk about this weird one here. So we start with A, B, and C. A is 4, B is that negative 1 that's in front of the x, and your C is 7. So we start by doing A times C, so 4 times 7, which is 28. And our B is a negative 1. Then we set up our chart. I'm going to move it over here actually to give myself a little bit more space. Multiply to 28, add to a negative 1. And a lot of you might have gotten to this part, and you might have even started to list out your factors. So like 1 and 28, or you could even have done negative 1 and negative 28. You could do 2 and 14, negative 2 and negative 14. 4 and 7, or negative 4 and negative 7. And I do believe that those are kind of all the factor choices that we would have, but when you started adding these, for this first one you would have gotten 29, and then negative 29. For the second set you would have gotten either 16 or negative 16, and for the last set you would have gotten either 11 or negative 11. And none of those add up to a negative 1. So none of these work, okay? So when you get to this point, if you're in a problem like this one, where you're kind of stuck, because what we've been doing is trying to factor this by rewriting that middle term, but I can't seem to find those magic numbers that work, we actually are not going to be able to factor this one then. That does not mean that this problem isn't solvable. So you can't write no solution, because there is a solution out there. I just haven't taught you yet how to find that solution, because there's other ways that we could solve quadratics. Instead, what I need you to write for now is that this is prime, because it's just not factorable at the moment. I could solve it if I wanted to, but we haven't gotten to that stuff yet in our units, so we're not going to be worrying about that at the time. So just write prime and then move on to the next problem.